FHIR versus traditional HL7. What makes this standard so different? So this is an article written by me, but I'm going to read it out to you for those of you who just feel more comfortable watching a video. Forget everything you thought you know about HL7. FHIR is not just an upgrade, it's a complete game changer. In this article, we'll explore why FHIR is gaining so much attention and how it differs from traditional standards like HL7, V2, V3, and CCDA. So for those of you who already have some experience and have worked with these standards, you may be coming to FHIR and you may be wondering what this is. This is for you. Whether you're a clinician or a developer new to health IT, join us and understand the benefits of FHIR and its growing adoption in healthcare. We'll start by looking at older standards like V2, V3, CCDA, and why they were hard to work with, and how FHIR is exactly different, and governments around the world are like adopting FHIR like crazy. We'll take a look at why this is really happening. So before we dive into FHIR, let's look at HL7 V2 first. So V2 messages are pretty simple. So you send it in response to something happening, right? So it may be admission, transfer, or discharge. This is abbreviated ADT for short, or when a new observation about a patient gets recorded. Whenever that happens, the system handling this data will emit an HL7 V2 message to all other systems that need to be notified. Now, this is an example of such a message. Now, leaving the structure aside, the way you actually usually sent this was over a TCP protocol called MLLP. It stands for minimal level layer protocol, or it stands for minimal lower layer protocol, version 2. And this is a full extensive document about exactly how it works, but it was not it was not widely adopted in any other industry apart from healthcare. So V2 had its own messaging protocol. Now we do have HL7 V2 over HTTP, but still 90% of the time you will have someone who's communicating with MLLP. Okay, this is just how the message works. You usually have a message and an acknowledgement. Sometimes you can just have a message. You can just fire and forget as well. So you may notice that the different segments are spaced out by a pipe in the above message. So this is so these are all different parts of HL7 V2 message, and they are separated out by these pipes, and each of these are different segments. Now, you may be wondering, like, what do these short forms like MSH, EV, and PV1, what do they really stand for? Now, when HL7 V2 came out, you had to really pay HL7 to even understand what these different segments meant, because you had a license fee for accessing the HL7 V2 specification. And this is not the case now. You can kind of Google MSH or EVN and you'll get some websites that offer open documentation, but they probably still had to pay HL7 a license to actually display those documents. So HL7 was, that's how they made money, and I guess that's fine. SNOMED CT to this day makes money by licensing access to their content. But when you are making a standard and you don't, if a receiving organization wants to understand what something means, you kind of have to pay HL7 to really access the standard. So now that aside, HL7 V2 was also notorious for the variety of different variations between implementations due to a segment called the Z segment. So the vendors used to add whatever they want in this Z segments. So there is this saying with HL7 V2, once you've seen one HL7 V2 implementation, you've seen one HL7 V2 implementation. And I have faced this personally. In fact, we've worked with multiple HL7 V2 projects, and each EHR, let me tell you, has a different version of how they do HL7 V2. So you can't really write like a general integration for V2. You gotta know what you're gonna receive, and that's the only way you can properly handle those edge cases. So with all of these factors combined, like the usage of its own transmission protocol, blocking access to the specification behind a license, and usage of use case specific Z segments, and this is also vendor specific Z segments. This meant that the HL7 V2 specialists were extremely expensive. right? So if you wanted to hire someone on the market, you can't just take a normal developer and ask them to work on HL7 V2. It was prohibitively like behind a paywall, behind specific domain knowledge. So HL7 actually started working on V3 because of this the last point, actually, because of the proliferation of different HL7 V2 variants and profiles. So they thought, okay, let's work on V3 and let's fix all of that. So HL7 V3 aimed to correct the deficiencies seen in both HL7 V2 and CCDA by adopting a more rigorous model-driven approach. It was designed to be more comprehensive and well-defined, with well-defined data structures and improved semantics. Now, HL7 actually spent close to 10 years refining the specification, and what came out of it was this class-based diagrammatic representation of everything in healthcare. So this was called the RIM, or the Reference Information Model, the Reference Implementation Model. And this was a significant milestone. So they tried to kind of boil the ocean and represent everything that can possibly be represented in healthcare. And they did that using, it's basically entity relationships. So if you are aware about, the semantic web and the standard which talks about triples, it was similar to that, but except it was at a more, it was not that granular. So they had these different entities like actors and participants and roles, and there's a bunch of different things, but they can relate to one another in different ways. And all messages that talk HL7 V3 have to kind of know about these classes and implement those structures. So it had an ambitious objective, but it faced significant challenges in gaining widespread acceptance. Now, its complexity was much, much higher than V2. And again, the only HL7 V3 implementations that were successfully done were by the creators of V3 itself, and with a lot of funding, probably in the billions of dollars. So many organizations, actually, like most of them, just found it too complicated and resource intensive to just use, right? So this is a good, saying. The rigorous consistency of HL7 V3, initially seen as an advantage, turned out to be a major disadvantage because healthcare institutions were inconsistent in the types of data they wanted to capture and transfer. So the problem here was HL7 V3 was a really good standard and it was very consistent, but healthcare didn't want such level of consistency. And as a result, V3 finally failed. And CDA is kind of a version of V3 which took the whole document idea to its logical limit. So like HL7, you take that, you put in documents and you add XML and you kind of get CDA. Okay, CDA stands for Clinical Document Architecture. So now a group of people with interest in both HL7 and XML met in the Kona mansion. So they did something, and they kind of used some bits of the HL7 V3 reference model, and this finally became what is known as the Clinical Document Architecture. Now, as a standard, CDA was pretty successful, especially because the US regulated all EHRs to send CDA documents, especially CCDA documents. So CDA plus continuity of care plus the US meaningful use stage 2 basically gave rise to CCDA. So you can think of CCDA as a profile or a specific variant of CDA. And this is how a CDA document kind of looked. It's basically XML, but the advantage of a CDA document is that it could also be rendered for human consumption. So you can kind of like just open a CDA XML file in a HTML browser, and it will show you a nice table, and everything will it'll kind of look exactly like this. And it is XML, but it also has markup for HTML, and it also has structured data definition here as well. Okay, so that's kind of how CDA and CCDA works in general. Now, CDA was mostly successful. Even today, you still have a lot of people adopting CDA, and people never really adopted HL7 V3 with the same degree of fondness as they adopted V2 or CCDA. So you don't really have V3 implementations, but you still have like V2 implementations and CCDA. So it's pretty prevalent. Now let's take a look at why FHIR is different. So now what actually happened was right after they realized that the HL7 V3 standard was kind of a failure, they launched a task force. And this was called the Fresh Look Task Force. And there were actually two competing standards at the time that was going for this next big thing in HL7. One was Resources for Health by Graham Greene, which basically became FHIR. And the other was actually called Clinical Information Modeling Initiative, or CIMI, and it was by Stan Huff. And this was actually based on open air archetypes. Now it didn't really catch on and people didn't really like adopt CIMI, but like FHIR became the main thing. But let's look at why FHIR, like how FHIR really came about and what was the inspiration. So FHIR was strongly inspired by Basecamp's high-rise CRM APIs. Now, if you take a look at any modern API, right, like for example, Stripe or High-Rise is a good example. It's not that well maintained by Basecamp, but this is it, right? You have a bunch of API endpoints and you have these bunch of resources, and you just do CRUD operations or like create, read, update, delete operations on these resources using HTTP verbs like get, post, update, put, delete, right? Update as well. So this was the first time HL7 was kind of using what was already there. So instead of reinventing the wheel with its own protocols like MLLP, FHIR just used what already worked for other industries. That is HTTP, JSON, XML, the RESTful interfaces, and so on. FHIR started defining how RESTful interfaces can be built on a data repository that will house all healthcare information. We do you can check out this other article where we do a beginner's guide on like what FHIR is. We have another video as well. I'll put that in the description below. But basically you can interact with a healthcare API or a healthcare enterprise the same way you would any other industry. And it's not that different. And like, this is basically HL7 just catching up with the industry standard, which, in this case, it's Web 2.0 on the internet. So this is a complete change of paradigms from the previous messaging and the document exchange that used to happen with V2, V3, and CCDA, because none of this really cared about the current state of the patient. It was all about like, okay, if something happens, send me a message, or this is a document that was documented at some point in time. HL7 FHIR was the first time that they were doing RESTful interfaces, and they were looking at healthcare as this storage mechanism or this repository of data that anyone can access, and you have a common source of truth. Now, specifications that complemented FHIR, like Smart on FHIR, obviously made it even more simpler to work with FHIR and authenticate with servers without needing back and forth between organizations. And I think that's the thing, like whenever there is a lot of back and forth between organizations, that's when you completely kill innovation and any sort of productivity. So the other major factor here is that FHIR is actually open source. And this was the first time that HL7 was properly doing this. So FHIR was initially called Resources for Health, and it was a project worked on by Graham Greene on the side. But then when it became incorporated into HL7, Graham was very clear that he wanted to publish it under an open source license. This became FHIR as we know it. And again, like I have a short clip here of Graham explaining the impact of this and how this changed things for him.
Another one is when I convinced the HL7 board to adopt a formal open license, open source license for the work, and my life really never has recovered since we've made that decision. Funny, some of the old guys on the board, in the old commercial mode, they were like, you've wrecked everything when they lost the vote.
So, I mean, it's definitely that FHIR has exploded in popularity quite a bit, and probably because of its open source nature, right? So while the previous HL7 were paid to access and had a huge barrier to entry, FHIR for the first time can be accessed on the internet and is free for everyone. You can do it right now. Like just click on this link and you open the FHIR standard specification. You can explore everything that is on FHIR. Nothing is behind a paywall or a restriction, right? So this also gave rise to a lot more educational content, like what you're seeing now, or you have hundreds of open source implementations of FHIR today. So if you go to this Confluence website, just the number of reference libraries and implementations is mind-boggling, right? This was never the case for something like V2 or CCDA. If you check V2 for Python, you'll probably have like half a package that's available. So the other focus is FHIR is simple and easy to use. So there is this thing called the 555 rule of FHIR. So 5 seconds to find the specification on the web, 5 minutes to understand it, and 5 hours to have some working code. And this is very much possible. You can actually build an app in 5 hours. We do that with our FHIR bootcamp. People who don't know how to code are even able to build a working app in less than a day. And that's impressive, right? So in contrast with the extraordinary domain expertise required to understand something like HL7 V3, FHIR is simple. And there is this philosophy called better, like worse is better. And it states that sometimes things that are worse than the correct implementation is better because it's just simpler to adopt, right? And it's, you can take a look at this link in the Wikipedia article on how the worse is better came to be. But this is very interesting. And I think FHIR is one of those where it is worse than, like, let's say V3 in terms of correctness, but it's simpler. So it gets adopted faster. So FHIR also adopts the 80-20 rule or the Pareto principle when modeling information. So whenever a data point is modeled in the core specification, it makes sure that it's something that's required by 80% of the vendors and 80% of the use cases. Then the remaining 20% needs to be done through profiling and implementation guides. Now, the other thing is the FHIR community. So last time I was at a FHIR Dev Days conference, so I was giving a talk on generative AI. The energy there was something else. Like, let me tell you, it was not like, the usual conferences where you go and you have a bunch of stakeholders talking about something, and it's completely different. Like FHIR Dev Days especially was just this developers nerding out without any shame, right? So that kind of a community where they really look at people who are doing things on the bleeding edge and then encouraging them. And I believe like FHIRly and Health Samurai have been doing an excellent job at this. They've been fostering this great community. HL7 International as well. Now HL7 also has different national bodies, like they have India, Finland, and the Netherlands and so on. So a lot of lawmakers also come and attend these events. So what happens is that now lawmakers worldwide are adopting FHIR. So for example, this was a survey done by the State of FHIR report by HL7 and FHIR International. And you can download the PDF. It's available in the blog. So almost 16 countries have mandated FHIR in their regulation in some way or another. Now, 31 said that there is some regulation in place that prescribes the use of standards, and 16 have mandated specifically FHIR, and it mentions FHIR in the regulation. Now, again, US being one of the main ones that initially did this, and 4 have advised. I think this is like Australia and some of these countries that are still in the phase, but I think with most of the EU moving towards FHIR and most of the US already on FHIR, what will probably happen is that the EHR vendors will just find it easy to implement FHIR than not implement FHIR. So when they are taking an EHR solution and they are, going to other countries, they would just implement FHIR, and the country does not even need to mandate it. It will automatically flow, right? That's kind of what happened with HTTP. It's not like a mandated standard by any country. ARPANET happened and then it immediately just became a thing, and now the internet runs on HTTP. Now this is a list of different countries that have adopted FHIR. We've linked to the different FHIR implementation guides and the profiles here. Of course, the US has the different certification programs, and EU is also working on the EU health data space, the European health data space, and this also talks about FHIR specifically. Specifically, the the IPS or the International Patient Summary. Now, that's basically the gist of this article. And if you found it useful, give it a thumbs up. And if you want more information, you can check out the description and you'll find the article down below. We'll also have multiple, we have webinars that we conduct regularly where you can, where we talk about FHIR. So we have a 90-minute FHIR masterclass that you can sign up for. And we also have a FHIR bootcamp where we teach people how they can build applications on top of FHIR. So if it's something that you're interested in, do check it out. And thanks for watching. I'll see you again in the next one.